Good morning. Today we will start the acid gas treating system and how it is getting treated and what are the chemicals used, how the process is happening. We will discuss in this lecture. We do some solving some problem also. Previous lecture we have seen that gas, whatever you are getting from oil well, condensate well or gas well, it will be having mixture of H2S, CO2, water, carbon dioxide, CO2, carbon dioxide, some other component also. So, one of the most important component is acidic gas. So, acidic gas includes H2S and CO2. Okay. So, in certain wellbore, if only CO2 is there, there is no H2S. So, it will be also considered as a sweet gas. Okay. Only CO2 will be considered as sweet gas, but this is sour gas. Okay. Why sour gas? Sour means acid, right? Acid is sour. So, H2S will be reacting with water and it will create H2SO4, H2SO3. Okay. Similarly, carbon dioxide, it will be producing H2CO3 or carbonic acid. Okay. So, these acids are important because this will create corrosion. Okay. And some cases hydrogen pitting, if H2S is there, hydrogen pitting, hydrogen pitting will be there. So, metal surface will be small pitting or rupture will be created. So, that will be creating next problem. So, it will be reducing heating value. So, reduce heating value. Okay. So, sales value, heating value reduce means sales value also reduce sales value, sales value. And another thing is that H2S is lethal, it is very much dangerous. Okay. So, if oil and gas system is having lots of H2S, so that can be dangerous also for human life, and it will be reducing life for your metallic part. It will be creating hydrogen pitting. It is not giving any heating value. Unnecessarily, you are creating trouble. Pipeline and other machinery will be eroded, corroded. So, you have to avoid this one. So, you have to separate. If you are not separating, then problem will be persisting. Carbon dioxide will be creating corrosion also, but it may not have this lethal value. But if carbon dioxide is having more than certain amount, then may be lethal. But normally H2S is called lethal gas. Okay. So, 0.13%, 0.13 ppm if H2S is there in a gas by volume. So, this gas will create smell, pungent smell. Okay. If we have 4.6 ppm, so smell noticeable. So, 0.13% is small smell may be there, may not be there, but some smell may come, but 4.6 is there, but strong smell you can get. So, noticeable. Okay. If we have more than 200 ppm, so in that case you have smell fatigue. So, you will not get smell, actually smell fatigue will come. Okay. So, no smell. If you have more than 500 ppm, so in that case no smell, breathing issue will be coming. Then 700, more than 700 to 1000, so death. Okay. So, 500, more than 500 is there. So, breathing issue and death can be coming. 700 to 1000, then immediate death possible. So, these are the 1000. So, this is the most dangerous thing actually. If you have more H2S, so you have to remove it. So, you see this picture I have taken from one website hnhu.org. So very small amount is there, then you can get odor, but if you have like 100, 200, 100 around, so in that case like eye itching, all these things will come, irritants will come up to 250, then 250, 500 you can see these people are going die, and more than 750 dead. Okay. So, you have to remove hydrogen sulfide. So, distinct rotten egg odor will be coming if you have very low amount, but severe irritation will come if you have 220 to 100. Severe eye irritation and cough and other thing will be coming if you have 100 to 50, but if you have more than 750, death within moment to minutes due to respiratory paralysis. Okay. So, basically it will be attack to respiratory system and it will be attack to your brain also. So, that way death will occur. So, gas sweetening process, solid bed absorption process, iron sponge. So, now you see, you have seen this gas H2S especially, it is having very much dangerous, okay, dangerous property. Now, how to remove it? So, there are several ways to remove. The solid bed absorption process like iron sponge, sulfur treat, some company name is there, zinc oxide is there, chemical solvent, amine, potassium carbonate, physical solvent like shell sulfinol. These are actually company brand name. So, that is why this shell name is there. Selexol the company name actually. We will see later details of these. Direct conversion. So, CLAUS process, LOCAT process, they will be converting directly H2S into sulfur and hydrogen. So, in that way they will be removing. Sulfide scavenger distillation can be done, gas penetration will be done, but because our time limited is there in lecture. So, I cannot discuss in everything, but a few things we will discuss in this lecture. So, solid bed absorption. So, this iron sponge, okay. So, what is this? This process applied to the hydrogen concentration low 300 ppm, low hydrogen concentration is there, H2S. So, in that case you can use iron sponge, okay. Operating a low or moderate pressure 50 to 500 psig pressure, okay. Within this pressure and within this H2S range, normally iron sponge can be used, okay. Carbon dioxide is not removed by this process, CO2 not removed, removed in iron sponge process, okay, not removed. Reaction requires slight alkaline solution, slight alkaline solution required to react H2S and iron. So, equation is that Fe2O3 2 plus 6 H2O equals to Fe2O S3 plus 6 H2O, okay. So, some water already there and 6 H2S, okay. Hydrogen sulfide you take, it become water actually. So, ferric oxide impregnated on wood chips which produce solid bed with a large ferric oxide area, okay. So, you create a sponge with wood with ferric oxide, okay. So, the surface area will be increasing. So, on the surface, once you get larger surface area, you pass your gas. So, gas will be absorbing your H2S and it will be creating sweet gas, okay. So, now you got Fe2S3, okay. Now, you have to recover again, otherwise again you have to supply Fe2O3 bar again and again. So, how to recover it? So, you have to increase temperature, okay. So, then what you do in this case to recover, recovery, RECOVRY, recovery. So, how do you recover 2 Fe2O3, Fe2S3 plus 3O2, 2 Fe2O3 plus 6S and S plus O2 SO2, okay. So, this reaction will be occurring during recovery process. Now, this is exothermic process, this is actually exothermic, this is exothermic. Exothermic means heat generates. When reaction will be occurring, it will produce lots of heat. So, when lots of heats are there, and if you are not controlling the reaction, then there will be fire. So, you have to control the supply of oxygen and control the temperature, so that there will be disastrous things should not happen. Okay. Tray must be removed after 10 cycles, because this after reaction Fe2S3 we are getting continuously, and when you are getting continuously Fe2S3, the tray one sulfur cake will be deposited on this system, okay, because you are producing sulfur, right. So, the sulfur cake, when it is deposited, so your gas will not be interacting with Fe2O3 again, or ferric oxide, and gas will not be touching, because sulfur will be coating these things. So, you have to remove these things after 10 cycle of operation. You have to remove, again you have to clean, again you have to put new type of Fe2O3, that sponge, then your system performance will be increasing. Now, similar way you got zinc oxide reaction. So, ZNO plus H2S, you get ZNS plus H2. Okay, this is also similar sort of reaction like iron sponge. Okay. So, at high temperature more than 250 degrees centigrade, 250 degree Fahrenheit, 250 degree Fahrenheit, the reaction will be occurring. So, a little bit high temperature will be required for this one. Now, another one is sponge, iron sponge reaction, another will be amine reaction. So, what is amine? Amine is nitrogen containing organic compound. So, okay, there will be three type of amine: primary, secondary and tertiary amine. So, primary, let us see what reaction happens when you are using amine with to remove your H2S. Okay. The amine can be categorized as primary, secondary and tertiary. Okay. So, primary will be more active. So, reaction will be quicker, and less active will be this one, secondary, and further lower will be this one. Okay. So, most active primary, then secondary, then tertiary one. Okay. So, amine is a organic compound. Okay. Okay. So, primary amine will be acting quickly or reacting quickly with CO2 and H2S. Okay. So, what is the reaction? Reaction is like this: 2RnH2 plus H2S. So, this is low temperature. What is happening? RnH3 whole 2S. So, this high temperature, reaction will be opposite. High temperature, reaction will be opposite. So, if you increase temperature, again you will get original amine. Okay. RnH3 plus H2S, again high temperature, this low temperature, high temperature. Okay. So, the reaction will be like 2RnH3HS, another reaction 2RnH2 plus CO2, low temperature, high temperature. Okay. RnHCOONH3 R. So, this reaction actually for monoethylamine or MEA, ethanol amine. Okay, MEA. So, this is called primary amine. This is primary. Okay, this reaction for this one. Now, if we have secondary amine, dimethyl. Now, if I have secondary amine, diethanol amine. So, DEA secondary. So, in that case reaction like this 2R2NH plus H2S, again high temperature, low temperature, this is low temperature, this is high temperature. So, R2NH2 whole to S, R2NH2 S plus H2S, again low temperature, high temperature, reaction like this 2R2NH2 HS, R2NH plus CO2, low temperature, high temperature, R2NCOO NH2R2. So, there will be some other type of amine also, but we are not going to further details. Just you remember these things, it will be okay for your basic study on how to treat amine and the chemical reaction. So, you see this amine process. Amine process will have one contactor column or absorber column. So, this will have trays actually. Trays will have like this. Okay. So, lean amine will be falling down from here and your gas will be going here. So, this is having H2S plus Ng, okay, natural gas plus H2S plus CO2, all this mixture will be there. So, you are injecting and it will be passing through this tray, these are called tray, okay. So, this is filled with amine, this will be amine, okay, and when fluid is going, it will be going through this, maybe another tray will be there. So, several steps of trays will be there, okay. So, one tray, two tray filled with amine solution. When it is going through this, it will create lots of bubbles, okay. So, that bubbles will be going and you are taking your gas here, and lean amine will be falling down from here, okay. You see I am making bigger arrows for lean amine and it will be creating layers here, it will be creating some layer, okay. And rich amine will be, some holes will be there. So, amine will be coming down, 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 down and it will be reaching here, okay. So, this is amine, then it will be going through rich amine channel to flash drum, hydrocarbon you separate, flash gas you separate, and rich amine you move with filter, heat exchanger. Then steel actually this is also one contactor type column, there you increase temperature. So, what is happening? Increase temperature here, temperature. If you see the previous slide where I said that if you increase temperature, reverse reaction will be happening. So, here you increase temperature, you create reverse reaction, you separate H2S and amine part you put again back to your system, okay. So, amine part will come here, it will go through this heat exchanger here, here, okay. This is amine line, okay. Actually amine going through this. So, different process will be there, heat exchanger will be there, you will have surge tank, you have pump, you have cooling system, because at cold temperature you are sending there. So, cold temperature amine and your acetic gas will be reacting. Then you got that amine acid gas free, acid free gas, and you are taking out to sweet gas. Here you can see sweet gas, okay. And the rich gas with amine plus your H2S mixed or reacted, that gas will be coming and it will be going to regenerator or reboiler section, where you separate again amine and acetic gas. Amine again you put into your contactor column or absorber or contactor column, you see contactor column, contactor, okay. So, there acid will be absorbed, gas separated, acid mixed with amine is separate in regenerator, okay. So, there you increase temperature, separate amine again you put there. So, this cycle will be going on. Hot potassium carbonate process. So, this is another process other than amine process. Here potassium carbonate is used to separate H2S. So, how this work? So, H2O plus CO2 plus K2CO3. So, high temperature, high carbon dioxide pressure is there. So, it will produce 2KHCO3. So, potassium bicarbonate, and if in reduced temperature, reverse thing will happen, low CO2, okay, and K2CO3 plus H2S, it will create KHS plus KHCO3. This is high H2S, low H2S. Okay. H2S alone cannot be removed unless there is a sufficient amount of carbon dioxide. Okay. So, carbon dioxide is must, okay, in this process. So, carbon dioxide is there so that sufficient amount of H2S can be removed. So, process is like this. You see this sour gas is coming, okay. So, sour gas is coming and you are putting into your absorber column, okay. There will be again contactor column type thing. This is absorber column, and the gas is coming like this. It is going to stripper channel, again pumping, cooler, mixing up, okay. And from here, whatever gas you got here, like H2S free gas, so that one you are taking, you are sending to sweet gas. Here heat exchanger is there, so those sour gas inlet and sweet gas is not mixing actually. This is only heat transfer, separate pipes are there. So, only heat is getting transferred, fluid is not mixing up, okay. So, this is rich mixture is going through this bottom, rich mixture is going to stripper, or there K2CO3 and H2S, that mix whatever reaction happened, that is getting separated. So, separated fluid again you are entering from the top after cooling, okay. So, this way this K2C potassium carbonate reaction is happening, and the whole flow process is like this. Direct conversion of hydrogen sulfide to S. So, this is a CLAUS process, CLAUS process. Okay. So, in that case what is happening, H2S plus 3 by 2 O2. So, SO2 plus H2O, SO2 plus 2 H2S, 3S plus 2 H2O. So, this first process is called thermal stage, and second stage is called thermal and catalytic stage, thermal and catalytic. Okay. So, first stage you are reacting and you are creating sulfur dioxide and water. Second stage the sulfur dioxide and H2S together reacting, and second stage sulfur dioxide and H2S is reacting and it is producing pure sulfur and H2O. So, directly you are producing actually sulfur, okay. Thank you very much. Next lecture we will try to solve some problem. We will see some mathematical calculation and sizing of this amine process and sponge process system, and we will see what are the different calculations. Thank you very much.